There we go. Go ahead and talk.
By golly, we're live, and hello, everybody. You science lovers, welcome to the SBAU Astro Hour. This is series number 13.
Wow.
The 24th of May, 2021, and we're going to have the 14th still in May. 1 week from today will be the last day. Welcome aboard. My name's Baron. Weekly podcast for the Santa Barbara Astronomical Unit and SBAU.org. Go online, join us. We're going to convene again at that incredible Museum of Natural History at some point in the future. Proud to have that vaccine in our bloodstreams. We're live from the homes of SBAU members and board members on Zoom, also streaming on YouTube. I believe that's SB Astro-Unit channel, or I'm not sure. You'll find us. Monday mornings, every Monday at 11 a.m. I like to call it the space news of the week from your local telescope and astronomy club. It's been here for a long time. It's had the name SBAU for a long time. Rocket launches and rovers, space stuff. Welcome aboard. Let's meet the Brain Trust, starting with the president who's not with us. He's under the weather, Jerry Wilson. I was hoping he'd get a little better, and maybe he's watching us so he can critique us. But Jerry's been he's the man and head Brain Trust guy, as far as I know. I'm proud to be right behind him, a heartbeat away. Jerry's being taken care of at home by his wife, Pat Forgy. At the bottom left of the screen, Chuck McPartland, our outrageously eccentric outreach coordinator. Chuck, you and Pat doing okay?
Good morning.
Hi there. Tom Totten is our wizard, former president of the club and technical guy, webmaster. I guess the main number is very simple, SBAU.org. Gets anybody that wants to join us, or it gives you details on how to watch the show here that we record every Monday morning. We've done 13 now as of today. And soon to join us possibly will be Bruce Murdoch, who was a longtime member. Tim Crawford. You know, Tim, if you're watching, he does watch us. You could call and get on board. He's the guy behind tomorrow night's telescope workshop, right, Tom?
Ron, Tim, he oftentimes will say comments on YouTube. And so I'm looking up at the YouTube screen and seeing if he's making any comments there for us to comment on.
Okay. Well, we miss Jerry. We hope he gets better. Yeah. And we'll teach him to go see family in San Diego. So we're going to have a special commentary later by our, I want to call him the out of work. Not really. He's retired comfortably, former Westmont College instructor, does have a doctorate, and editor of our SBAU newsletter, Tom Whittemore. How's Maureen, her wife, Tom?
Fine.
Everybody doing all right? Guys. And you're Pat, Chuck?
Yeah.
She's taking care of the cats?
Well, this one's in my lap right now.
Kind of jealous of you. I'm a cat guy because I can't have a dog. This hour, we're going to talk about, let's see, we'll have the night sky, and we got a full lunar eclipse in a couple of nights. We got the major gas planets playing games with their moons, NASA getting ready for the Mars helicopter Ingenuity to do its most interesting flight yet. We might talk some more about Mercury and its tail. Apparently, they discovered a tail off of Mercury, somewhat like a comet. Speaking of comets, some heavy metals they found out there in some of those comets. Mm-hmm. So, and we'll also mention some of the silly cartoons that Jerry Wilson, the president, sends us. So you guys go on board. Where do you want to start, Mr. Chuck McPartland? Let me ask you this. Outreach is on hold, but you're available anyway, right?
Outreach is creeping back. I'm going to do a Kachuma this weekend coming up.
Really?
But we're not going to have telescopes, so it's just me pretty much, and it's going to be limited audience and just a slideshow in the outside theater.
Oh, neat.
Is it for us in the club, or are the neighborhood campers?
No, it's an outreach, so it's for the campers out at Kachuma Lake.
Okay, you going to wear a mask?
When I'm not blabbing, yeah, probably.
Be honest, we're out there, we're dining out, aren't we, by now? Because we can. We were one of the first to get both shots. So I do have a Thursday luncheon, and so far we haven't gotten any diseases. Well, let's talk about, let's go right to the Wednesday night lunar eclipse. What's the deal on that? Any of you, McPartland, Chuck?
It's early morning, so you got to kind of be night owl, I guess, or an early morning type. The partial phase starts at around 1:48 a.m. our time. Oops, I just lost that.
I didn't. Well, that's a blood moon. If I ever saw one.
Yeah, but I lost my times. Let's see if I can get this out of.
Well, I can tell you the time. It's on Wednesday morning.
Yeah, but that doesn't have the partial phases and things.
Okay, it just says partial lunar eclipse. Partial. I thought it was a full. You said it was full.
It's full.
Oh.
The partial phases start at 1:48 a.m.
Oh, I see. It starts. Okay. Our shadow, the Earth's shadow, is going across the moon.
And I can't get to my because this has taken over full screen. Let me try to get out of full screen here.
Okay, well, it's going to be in Scorpius. Is that where the full moon is? And it gets as full as it gets sometime during this. I guess that would be as full as it gets when we cover it with our shadow, wouldn't you say?
Yeah, but that doesn't happen until about 4 a.m.
Okay, so it'll be about 3 hours that the Earth's shadow goes across the moon.
Yeah, creeping across it. And then the totality only lasts about 15 minutes.
Okay, and it'll be seen where?
Well, it'll be off in the west.
Just here.
Oh, it'll be seen in the western hemisphere, in the western part of the U.S. is as far as the U.S. the western part gets the views.
This is not like a solar eclipse in which the shadow of the moon goes across the Earth in a path. Everybody that can see the moon will see the eclipse on the planet, right?
Yes,
including South America.
I don't have. Since this is full screen on here, all I can see is what Tom is showing. And I believe parts of South America can see it. They should be able to if they're at similar longitudes to what we are. But they're more to the east, so they may have trouble.
But that eclipse time is when it's sunny over in Asia and Europe, right? Daytime over there.
Yeah, on the opposite side of the Earth.
Okay.
But the sun is just about to rise for us. So it's already risen, of course, on the East Coast by the time this happens. That's why they're not seeing it. And so we're gonna have totality ending just a couple of minutes within half an hour before sunset, and then sunrise rather than sunset. And so it's definitely an early morning thing, a dawn, slightly pre-dawn thing.
So okay. Chuck, what is the effect of, I guess the moon is going to be closer than normal. So what effect does that have on the lunar eclipse?
Well, if it were central, it would, of course, last a little bit longer. The moon's a little bit bigger. But we're very much off toward the edge of the umbra. And so the top part of the moon is going to look a little bit more illuminated than the rest of it because it's near the edge of the central shadow. And it won't really have that much effect on the duration for us. It's only like 5% larger when it's very close like this. So it's a small amount of change. But yeah, that was a good view there that showed the red moon with a little bit of bright on the upper part. It's not going to be quite that bright, but it will look brighter on the top because the umbra won't be covering the entire. The umbra will be covering the entire moon, but it's near the edges of the umbra. It's a little bit brighter.
Tom, what more
the penumbral phases are a little harder to detect, but they will also occur. Starting at 1:48, and then they will continue past when we can see the moon for people off in Asia.
So it's 50-50 that our side of the planet would get it being nightfall, or the other side of the planet, or any side of the planet. Just random, depending. How often do we get lunar eclipses?
Lunar eclipses a couple of times a year.
Okay.
Sometimes 3 or 4.
What does the name blood moon and flower moon? This is a flower moon, supposedly, late May.
Tom, you know this.
Tom Whittemore or Tom Totten?
Probably Tom Totten, right, Chuck?
No, I'm not really familiar with those odd names, no.
Okay, so a lot of these names that they're given to these full moons now are either Indian lore, American Indian lore, or other societies' lore. Because our calendar is kind of moon-based, or was, a month is a month, a cycle of the moon. people gave names to the full moons depending on the season. You know, there's a hunger moon when it's winter time and a worm moon when it's spring is beginning. So a flower moon is kind of a mid-spring moon when flowers are blooming.
Okay, as opposed to harvest moon in October.
Yeah.
Harvest moon, that's one of my favorite moons.
Yeah, and blood moon is just a lugubrious term that everybody started to use for when there's a total eclipse.
So Chuck,
Yes.
why does the moon turn red?
So the moon turns red because, as you can see here, blue light gets scattered by the Earth's atmosphere, and basically what you're seeing cast on the moon is the light of the sunrises and sunsets all around the Earth, which are reddish because the blue light gets scattered out.
Right. And that's why they call it blood moon. Yeah.
And that's where that blood moon thing comes from.
Yeah.
Is there any reason at all to point your telescope at it?
Well, it used to be that people would point their telescopes at it and measure when the shadow hit certain craters for timing. And
Okay.
it was dual purpose. It was, but mainly what it was for was to measure the extent of the Earth's atmosphere, you know, the fuzziness and things like that. And way early on, you could probably get some idea of the size of the moon, of the distances between craters and things by timing things like that.
Uh-huh. Well,
And
speaking of,
it's interesting to see in a telescope, but it's not. It doesn't really provide that much more compared to naked eye.
right. So
Binoculars often make it look kind of nice, though.
Yeah. With binoculars, you might get a real 3D effect.
Yes. That's one of the neat things I like about these eclipses is you get a sense that the moon is a ball. You know, you really do.
well, obviously, common sense tells you solar eclipses are only during daytime and lunar are at nighttime. Obviously, the sun's got to be on the other side to cast the shadow this way.
Yeah.
And I'm reminded of an old Jerry Wilson joke that he sent me, or somebody sent me, that said, I took a shot of the eclipse because everybody on the Earth, you know, was right there. Our shadow cast on the bright side of the moon, but damn it, I had to do it again. Somebody moved. But that's all right. You could do hand puppets. Okay, that's on Wednesday morning.
Yeah, and when we're in this kind of configuration of the sun, the moon, and the Earth, it means the line of nodes where the orbit of the moon passes the ecliptic are lined up with the sun. So it's eclipse season. So you usually 2 weeks on either side, you can get a solar eclipse of a lunar eclipse. And so coming
Really?
up will be an annular solar eclipse, but we won't be able to see it.
Right. Yeah.
So it'll be during our nighttime.
Yeah.
Okay. What do you know the north of the equator versus south? Is it just pick and choose, just like the lunar
It's
eclipse?
northern hemisphere. It'll be visible on the East Coast. I don't know
Right.
if it'll be annular on the East Coast. I think it'll be annular in Canada, but for the East
Yes,
Coast,
I think in Russia too, Chuck. Right.
Pardon me?
Russia. I think in Russia too. Right.
Yeah.
Yeah.
So it's definitely a northern hemisphere thing.
Mm-hmm.
So does it go without saying that if the moon is close in, you get a little on a solar eclipse, that if the moon is closer to us, you get a little wider path. Do you understand
Yes.
what I'm saying there?
Mm-hmm.
Yeah, and a slightly longer eclipse.
Okay. And so when is this annular? Give me the date on it, dude. Do you know?
Well, it's going to be 2 weeks after. So it's going to be at the new moon. So 2 weeks after this one.
Mm-hmm.
Really? So
Yeah.
we just happen to be ensconced, the Earth, exactly in the middle of the ecliptic of the moon's orbit, so that on one side it gets our shadow, and the other side we get its shadow. It's amazing.
Right. It's the nodes of the moon's orbit are lined up on the ecliptic right now.
Okay.
And the moon is full or new when it passes through there.
Mm-hmm.
I mean, the nodes
Fantastic.
always stay there, but it's the fact that the moon is full or new while it's there.
Well, I got to tell you, I might see the end of it. You say 4 o'clock in the morning, I think, on Wednesday, right?
Yeah.
Yeah, I could probably see that. I still get up about that hour, you know, my radio hours. In
So
fact,
Chuck, I got a question. What does that Saros mean again? The Saros cycles.
Cerro cycle is like a 19-year cycle or an 18-point-something year cycle based on the moon and how its nodes progress through the ecliptic. And so you'll get a series of eclipses separated by that number of years that are very similar in their duration And their path on the Earth, of course, moves a little bit because it's not exactly that number of years, but you get a series of similar eclipses. So they're called Cerro Cycles.
Right. Yeah. Yeah. It's 18, almost 19 years, right, Chuck?
Yeah.
Somewhere. Yeah.
18.6 something.
Yeah. And it's because the orbit of the moon, it precesses, and so you get this phenomenon.
Precesses. What does that mean?
It wobbles
Doesn't
like
stay
a top.
Yeah. It doesn't stay in one spot. It just moves.
Well, of course it moves. It's constantly moving. I
No,
don't
but
know.
No, these points that Chuck's talking about, these nodes.
Oh.
Yeah, the
Okay.
nodes. It's like the axis is wobbling, like a top wobbling around.
Oh.
Okay, I managed to get out of full screen here and get the time. So totality for us starts at 4:11.
Okay.
And then maximum eclipse 4:19, and totality ends at 4:26.
Okay.
And then
So
the sun
about-
rises at 5:50. So
I'm up. But would it be fair to say that the astronomical world probably won't get up as a mass, lemmings putting up, or do you guys just sleep through it, or are you, any of you?
No. Anybody in love with the night sky will get up.
Is that right?
yeah.
Yeah, there was one. We had a visitor about, 4 or 5 years ago, and it was in the middle of the morning. It's like three in the morning. It was a beautiful eclipse. Maureen and I were out with our friend in the backyard watching this. Do you remember that one, Ron?
Yeah.
Chuck. Yeah.
Yeah,
I'm sure you. Yeah.
Do you have a favorite between lunar and solar? Which is more exciting? Which do you tend to set up your?
I've only seen one solar, and it's pretty darn exciting.
Well, you got to be
Solars
careful.
are just an order of magnitude more impressive.
Yeah.
Is that right?
Oh, they are fantastic.
Yeah, you guys have
We
been
were
known
in
to.
Greenville, South Carolina, near where my brother-in-law Mark lives, for that one, and that was the one where I helped. It was at a black church, and a bunch of us, along with the O'Rourke's, made these little pinhole cameras for kids so they could safely look at it or cast the image of the disappearing sun onto the pavement or onto a card or something like that. Unfortunately, the one of the priests there, it's a Catholic church, one of the priests there, to celebrate the darkness, wanted light back. And so he launched these lanterns that had a candle in them, something we would never do here.
Yeah.
Okay. And one of them got caught in a pine tree.
Ooh, that's not
It was
good.
pretty crazy. It was pretty crazy. I think that was the 2017, that wonderful eclipse in August. I think it's August 21st, 2017. And I know Chuck was up in Wyoming with Pat and other folks. And, we are in South Carolina, Greenville. Went right over Greenville. That shadow, right over it.
It was
Here's
one.
the annular eclipse map. Tom has it up, June 10th.
Oh, okay.
And you can see it doesn't quite, the full annularity doesn't quite touch the US.
Yeah.
Maybe up there in Minnesota?
Yeah, polar bears will get a good look, huh, Chuck?
Yeah.
That right. Eclipse map. Look at that.
Yeah.
You're awesome, Totten. We love it.
Here's the lunar eclipse where you can see the visibility. Oh, that's
Aha.
okay. That's the darker part is where people see all of the eclipse. We're going to lose it to the sunrise, so we don't see when the partial phases end.
Okay.
Are the people inside?
South America.
Are the people inside the circles, the Arctic Circle, and I assume there's an Antarctic Circle? Are they totally out of the loop on lunar eclipses? Is that a
No.
middle of the Earth thing?
No, it probably depends on the season they're in, but
Okay, gotcha. Well, that's Wednesday morning. We got the word. You want to go down the other 4 days of the week, starting with tonight? Anybody with your
Sure.
comments?
I have to make a comment about how pretty Venus and Mercury are right now. It's just beautiful. Again, this is at sunset, after sunset. Venus is super bright. I saw it at least till like 8:30 or 8:40 here. Again, we lose a little bit of it because of some hills. And then Mercury is on its way to kind of join with Venus pretty soon, but it's getting weaker and weaker in brightness. And so that's a little bit tougher pickup. But Venus is just overwhelmingly bright right now. Okay.
yeah, Wednesday after the eclipse, if you go out in the evening after sunset, Mercury is going to be right up close to Venus, but it's
Yep.
going to be like 6 magnitudes dimmer,
Yeah.
which is like
Yeah.
1,000,000 times, or what's that, 100 or 200 times dimmer?
Yeah.
It's like 200
Yeah.
times dimmer.
Yeah. 5 magnitudes is 100. And so this is a couple of hundred. Yeah, Chuck.
Yeah. So you want binoculars, but if you get binoculars on Venus, you should be able to see Mercury nestled up kind of down and to the left. Very close.
Yeah, and I think if I remember right, it's 0.4 degrees apart, something like that. It's real close.
Well, according to President Jerry's talking points, Friday is the big day that Mercury and Venus get as close. It'll be in Taurus the Bull.
Okay.
Details.
Yeah, that makes sense,
For an hour after sunset, you can see them together, visible. One constellation away will be Mars. Near
Mars is going to hook up with Venus after a while too. Not tonight, but deeper in the summer.
Wrong. It's not after the eclipse. It is on Friday that they're very close.
Okay.
And I have two other words, possibly a constellation I've never heard before: Kappa Geminorum and Pollux. Is that a star?
Those are both in Gemini, so that's why it's Geminorum.
Mm-hmm.
Oh,
plural. It's plural.
So it moves from Taurus into Gemini. Is Gemini follow Taurus?
Well, that's Mars we're talking about now.
Oh, I see. Okay, you got to look over there. Got the old zodiac. Well, jump around the week. Tonight is let's see, center of the Milky Way in the constellation Sagittarius. Look south to the Teapot asterism by 1 a.m.
This is really early in the morning again.
Okay, well, those are your hours, McPartland. Several stars by 1 a.m. Zeta, Tau, Sigma, Phi. Sounds like a sorority convention. Sagittarii. And farther west is Scorpius. That's tonight. Not sure if that's on the screen.
Yep.
If it is that Tom Totten is just awesome. That is this evening, the 24th, Monday.
Yeah. If I could just pop in something I would mention before we came on board here. I've just had a lot of fun. There's a fellow named Matthew Wedel, Wedel, who for the last 5 years has been writing a wonderful column called Binocular Highlights. It's just really good. Oh, Sky and Telescope. Sorry, it's in Sky and Telescope. And in the June issue of Sky and Telescope this year, he mentioned this little seashell asterism that is very close to the star in Hydra called Alphard. Tom, I don't know if you can do that, Tom Totten. I don't know if you can pick up the star Alphard, Alphard, and its environment.
Which constellation is that?
Oh,
Hydra.
It's in Hydra, Tom.
It's the heart of the
I'll tell you about my experience last night with this. It's really neat. Let's see if Tom gets it. Anyway, if you take out a pair of binoculars, okay, there's this beautiful red star in the southwest part of the sky. Okay.
Depending on what time, but yeah.
yeah. So I picked it off about 9, just roughly last night. And at first, I didn't think I could get this little seashell. It's really cute. It's near a star called 24 Hydrae. Okay, and Wedel writes about this. He's a wonderful column. And so at first I thought, well, I'm probably not going to get this in binoculars. So I brought out the little 85 millimeter telescope. Boy, was it there. And then later on, when I got more confident, I pulled out my bird binoculars and bang, it was there. It was pretty easy to see. It's little star, like a little seashell asterism. Okay, he calls it a scallop,
And it's a bit, what is it, a red giant?
No, it's probably Alphard. Probably Chuck is it's probably red giant, huh?
Alphard is a red giant, but the seashell asterism is a grouping of stars, like a little mini constellation, like the Pleiades.
Yeah, it's really neat. It's really neat.
Huh.
So maybe Tom is looking for this to pick it up.
There's Alphard.
Okay,
if we zoom in on it.
That's the ceiling of Gladwin Planetarium.
His column is, he promised 5 years ago, he promised not to do Messier objects. And he said that forced him to look for brand new things. And, that's what he's doing. He's just looking for brand new things people can enjoy.
Okay. And I think, I'm not sure how well this is going to show up on here. Is that it, Tom?
This little group of stars here
No,
above Alfred?
it's
I thought it was down and right from Alphard.
that's correct. That's what I saw last night. And
Asterism.
it's pretty close to Alphard. It's pretty close.
It's called the seashell asterism.
Well, he was calling it that. I don't know if it has an
that's
official
what
name.
he called it. You can name it anything you want.
Okay, well, are those asterisms pictured in all those cartoons you throw on the ceiling there during your pre-meeting planetarium shows, Chuck?
I'm sorry, I didn't catch that, Ron. What'd you say?
Do we get all those asterisms in that incredible canopy, or?
No, you wouldn't. I mean, this wouldn't
Red.
be listed in the planetarium list.
Yeah. Well, it's not quite coming out on this particular map, but if a person would go out with binoculars, hook into Alphard, that person will definitely see this little asterism.
Yeah, I'm trying to bring it up from Sky and Telescope, but I
Oh,
don't know.
wonderful. Good. Yeah, it was the June issue, Chuck.
Yeah.
This guy's really good. He's just a wonderful writer. I really like him. Okay. And every now and then he does toy with Messier objects, but his promise was not to.
Now, is this Aldebaran you're talking about?
No.
Aldebaran is in
Alphard.
Taurus.
Alphard,
Okay.
in Arabic, it means the solitary one.
Because
It's kind of it's in the water part of the sky, right? And there's not a lot of background stuff out there, and so it looks very lonely.
okay, well, I took down notes from Jerry's talking points about a double star, Aldebaran.
Alberio.
Oh, it's
Alberio. Yeah, that's
Okay.
something entirely different.
Okay, that's in a totally different part of the sky.
Right, it's in Cygnus. I was just going to mention the other thing he talks about is how winter is going away and summer is on its way. So if you look to the southwest tonight, you'll see Sirius, which sort of represents, winter going away. And then if you spin around, you'll see Vega coming up, which means summer, it's on its way. It's really neat. He's very poetic in his writing. I really enjoy his writing.
Are you serious about that? Never mind.
Yeah, right.
We don't need that.
Yeah,
Okay.
and Alberio is one of our favorites for our outreaches in the summertime, because when you look at it through the telescope, to your eye, it looks like a single dim star. It's the nose of Cygnus the Swan.
Mm-hmm.
When you look through the telescope, you can see one of them's blue and one of them's gold.
Right.
It's a double star, one blue and one gold. And so Jerry calls it the UCLA star. Around here, we call it the UCSB star, but or the Cub Scout star.
Right.
The blue is the hotter of the two and the heavier, I assume.
It's the hotter, but it hasn't evolved as much as the other one. The other one's probably more massive. It's turning into
when I'm working with Ken Kilstrom at the Westmont Telescope, and we have Alberio in line, he's Stanford grad. I mean, he's Stanford all the way, bachelor's, master's, PhD. So of course I have to call it the Berkeley star.
Yeah.
Berkeley star.
Yeah.
But you can't see them without, you can see them separate is what I'm saying in the telescope, right?
Right.
Oh yeah, it's easy to split. There they are.
What if they're eclipsing one another?
They don't.
Occulting? They
No.
never do. Okay, we don't see it side on then.
Chuck, didn't they find out this line of sight and they're not really going around one another?
For years, people have been arguing whether it's a binary system or whether they're just a chance lineup, whether they're a binary that they're gravitationally bound or just a double where they appear line of sight. And it's gone back and forth and back and forth. And most recently, they've decided with some Gaia measurements that they're probably a double, but there's still a chance that they might be weakly gravitationally bound. So they're kind of hedging their bets on that one. And I believe the red giant one of the pair is itself a double, a very, very close binary.
Wow.
But not resolvable in a telescope.
You're kidding. It's triples.
Yeah, so it's a spectroscopic binary.
It's spectroscopic, yeah.
Wow. That's kind of like Proxima Centauri, isn't it?
Yeah.
Mm-hmm.
That's a triple, I think.
Well, Alpha Centauri system is a triple, and Proxima is the closest one of that.
Okay.
You probably should
That's
explain
actually many more stars. because I think
What?
alpha is a close double. I'm not sure.
Tom Totten, what did you say?
I think we should explain what spectroscopic double or triple or binary means.
Well, okay, so you can't split it in a telescope and see that there are two stars there. But if you take a spectrum, you can see that the spectral lines, which are caused by the different elements in the atmospheres of the stars, split and move apart.
Right.
So,
right.
you know, you see this kind of stuff going on, except my finger disappears there.
Yeah.
From that, you can imply that there are two stars moving, and the Doppler shift is causing those lines to move apart.
Well, we're not talking about something unusual. More than half the stars up there are at least doubles, right? If not triples.
Yeah.
So how many of them can you separate? Is this one of the few that you can actually see two separate stars? Is that a rarity?
Well, there's a whole spectrum of those.
Oh, yeah.
Spectrum again.
Yeah, good pun.
Yeah.
Well, speaking of spectrums, can we talk about the heavy metal discoveries on comets, gentlemen?
Yeah.
Here's what I have written down. Unexpectedly, they found inside the bodies of the central part of the comet some heavy metal. Which two did Jerry say? Which two big heavy? Nickel?
Nickel and iron.
That's big parts of your 5-pound meteorite that you like to pass around at star parties.
That's right. And that's, you know, those are common materials out there in space because they're the sort of the end stage of fusion.
Okay. They're also the same makeup of most asteroids, I would assume.
A lot of them, yes.
My thinking is asteroids have less water, less frozen ice, and that's why you don't see tails coming from asteroids.
Right. There's a continuum there too, where some have more ice and some have less. So you occasionally see an asteroid sprout a tail.
And last week
we group of asteroids called centaurs that seem to be sort of burnout comets. So they still have some ice and occasionally have tails, but they're in these orbits between like Neptune and Uranus out there.
Right.
So they're not in the main asteroid belt.
Well, can we touch on, speaking of comets and what it has in common with our innermost planet? This was brought up last week, but I think Jerry probably wanted us to talk about it. Something we've only recently learned about the planet Mercury, which is the little dinky one and closest to the sun. It has a tail, and it's
that's not a recent discovery.
That's not.
No, we've known for a while that it has this tail of ions that are being driven off of it by the solar wind. But the fact that it's easily visible from the Earth, or not, I guess I shouldn't say easily, but it's visible from the Earth without special equipment is kind of new.
Okay. And the
so
reason
and I'm not sure if this is going to still hold, because this was last week we talked about this, and Mercury has now changed its position relative to the sun. But because of the positioning where Mercury was relative to the sun, it was easy for us to see that ion tail. It was kind of streaking directly away from the sun, and so it was off to the side of Mercury. And people have been taking pictures of this with sodium filters for a while, because it's mainly sodium ions that are fluorescing with this yellowish light. But just recently, with this good appearance, some people just tried without sodium filters to take photographs of it. And they took a series of 30-second exposures at ISO, I think 3200 or 3600, and stacked them. And here, this is an image here. You get the idea of what it looks like as this faint tail coming off of Mercury. It's
What's
because the sodium ion fluorescence is so bright and comes through our atmosphere well that you get a chance to see this. But I think Mercury has moved now to the point where that won't be quite as easy to see.
But it's sodium. Of all the many, many elements on the periodic table, that's the one that goes mostly? Not iron,
that's the one that fluoresces really well. It gives bright light that's easy to see. There's probably a whole zoo of particles being blasted off Mercury here, but that's the one that fluoresces and makes it easy to see.
Here's an interesting article here about a MAVEN that's going around Mars. It detected metal ions from comet sliding spring. So somehow it was looking at, as it passed through near the atmosphere of Mars, it picked up all these different ions of metal ions. And look, it's a sodium, magnesium, potassium, chromium, manganese, iron, nickel, zinc. They all spiked as the comet went by.
Yeah.
So I'm surprised that a comet, has a detectable amounts of metals in its atmosphere as it shoots by.
There are rocks in there,
Well, can that lead us to Perseverance, as long as we're on Mars in a minute? After I do a quick, this is equivalent of our commercial break, gang. If your school or organization would like to schedule a virtual outreach involving an online demonstration or lakeside like this weekend using Zoom, in some cases, lots of graphics and photos, contact the man, Chuck McPartland. I got it here, outreach@sbau.org. Are you getting a lot of emails on that? That's not your own private first and foremost email address, is it?
That's my official AU email address. It's kind of a little harder to use than my normal one, but some people have asked for outreaches there. Schools are kind of winding down right now, so we're not likely to get many of them making requests.
Like everybody, we're looking forward to a full fall, maybe back at Herron Hall at the museum, and out doing our outreaches, and we get to see people that we miss, folks like Martin and Janet Meza. Somebody tell them we think about them. I think they're doing okay. Tessa Flanagan and her main squeeze, a guy named Kennedy, I think is his last name.
Duff Kennedy.
Okay. And Art Harris, is he okay? Is health all right?
Yeah, Art's doing great.
He's in charge of equipment, stuff for sale and whatnot. Edgar Ocampo, did he make it back from the Philippines? I guess he did, didn't he?
He's been back a long time, yeah.
Has he? All right, he's crazy. Colin Taylor with his wide brim hat, our treasurer. Tim Crawford, I'm not sure. Do we know if he's listening or on board this morning, Totten?
No, I don't see anyone making any comments. So,
well, maybe this is a good time for you to quickly tell people how to join your group tomorrow night. Sometimes Whittemore is on board. Jerry, I'm not sure if he'll be calling in, but it's another Zoom thing every Tuesday, right? We build telescopes and talk about them and sell them. And
right. If people are interested in getting information about their telescopes or astrophotography, they can contact me at webmaster@sbau.org, and then if they show an interest, I'll give them the Zoom link and they could tie up with us and see what we're talking about. But any questions, I think, will come first. So if people have questions of how to repair their telescope or how to use it or how to do astrophotography, we can try to get to those people first. So yeah, if you contact me at webmaster@sbau.org or before Tuesday nights, I'll try to get you in and get your web link to you, so that Zoom link to you, so you can join us.
And that's 7:30 to 9 on Tuesday nights. Every Tuesday.
That's right.
Were all three of you gentlemen on board last Tuesday? Just curious.
I missed it.
No, I was not. I started this thing and just I can hardly wait until we're live again. I mean, really live.
I went to one of them, and
they're still struggling with that 8-incher.
Oh.
Yeah, I record the meetings and they're on the YouTube channel. So if people click on our link to YouTube on the front page of the website, sbau.org, that link will take you to the YouTube channel, and then you can see our past telescope workshop meetings and these programs as well. So lots of information. If people want to hang out there, you could hang out there for hours now with all the meeting information, meetings that have been recorded there.
Tim, his name is Tom, but we call him Tim. Tim Crawford was sharing a lot of his ronchograms from his mirror, where he was trying to get just the right form. And this is where you look at the mirror through a grating, and it imposes this striped pattern on the image that you see. And from the shape of the stripes, you can tell the condition of your mirror. And so I saw a picture of this, I don't even know who it was, some pop star these days, some young pop star that was getting an award, dressed in this black and white striped outfit that had these curves on it, that it looked very much like a ronchogram. So I sent it off in an email to Tim saying, boy, when you see this in your ronchogram, you've got a turned edge. So,
that's pretty good.
I can't get the word you're saying. Rockygram? What's the word?
RONCHI.
Right.
American
who invented this diagnostic back in the, I think, 1930s.
Okay, is that sort of like the Dobbins brand of telescope, or Dobson, or
no?
Well,
No,
it's similar to that,
no.
that it's a name that's applied to it, but
Right.
there it is. See,
There
here's
is
a rocky.
Okay.
Wow.
See, because the mirror is curved, it's going to throw bias into the curved structure of the return light. So you test your mirror at the radius of curvature, which is basically the generator of that surface of the mirror. If the mirror were completely spherical, those lines would be straight, okay?
Oh.
But because we make mirrors that are parabolic, okay, another structure takes over the return beam. And I have a program basically that allows me to draw these things and then compare them to what Tim is reading. These are recent things that Tim has been sending me, and I've been in touch with him, usually just to Tim, telling him what I think, okay, and what he might do with the pitch lap and stuff like that. CC spelled RONCHI. It's pronounced Ronchi.
Does anybody in your field of astronomy work with radio telescopes at all? Is that an amateur field? Do they make metal?
Interesting you should mention that.
Yeah.
We have a member, he now lives in Missouri,
Yep.
but he still keeps in touch, Dr. Jerry Polivka. And he used to be in Czechoslovakia. He got out of Czechoslovakia, lives, now alternately, he's been here in the States and back to Czechoslovakia. Now he's in Missouri with his family. And his specialty was radio telescopes. And he helped with the ALMA, I believe, the Atacama Large Millimeter Array, or at least he helped with one I know in Mexico that's at high altitude, a large array of radio telescopes. And he actually had kits and directions for making an amateur small radio telescope using the little receivers that are used for satellite TV. Mm-hmm. And so you get these at, I think, 12 gigahertz and 2 gigahertz and 4 gigahertz. And he had directions where you go out and get an aluminum wok, that you'd use for Chinese cooking. And it's got a roughly parabolic shape. And you use this satellite receiver and then a little voltmeter basically as your display. And you could detect the sun and you could detect the moon. And you can detect people and trees if you pointed at things, because everybody's radiating in a spectrum. And it's not really visual, you don't get an image, but you get the little needle moving. And we would use it at outreaches at schools when it was cloudy, because telescope isn't much use. You can maybe look at a pigeon 100 yards away. with the radio telescope, you could have the kids direct it until they could see the sun, or they would point it at each other and see the needle go nuts, Wow. And he was just featured in a video by the Astronomical League celebrating, I think, their 75th anniversary. They were looking at other aspects of amateur astronomy, and he had a little video where he explained what you can do with a little amateur radio telescope. And so I'm going to put a link to that. I forgot to do it, Tom, when I sent you newsletter stuff, but I'm going to put a link to that in the newsletter.
Okay. Well, thank you. Yeah, and if Jerry's still listening, I would love to have an article from Jerry Wilson.
Okay, but
yeah, that's right. He's late, huh?
He's a rogue on his own. That there's not a whole branch of astrophysics that does this on an amateur level. That's a rarity.
Sure, there's amateur people.
Oh yeah,
really?
Yeah. Oh sure.
Never interested you guys.
He participated in so many outreaches at the museum with his little radio telescope and the little dial that would see the sun and respond to the radio coming off the sun. It was he was an integral part. Yeah,
there are lots of radio astronomy amateurs that can detect emissions from Jupiter, for example. They need bigger antennas, but they set out these dipole antennas in their yard or whatever. And Yuri in his video was actually talking about he managed to get this 1 meter dish that somebody was getting rid of and make a much larger radio telescope that he has out on his balcony.
Well, some technical questions real quick. I'll try to keep them short. The radio spectrum is below color. It's below the color band on the electromagnetic spectrum, right?
The frequency, yeah.
Yeah, the frequency is a little lower. which allows it, well, for one thing, you have the same concave, instead of a mirror, it's a metal sheet, right? That
Yeah.
reflects the radio waves.
A dish, they call it, yeah.
And a radio telescope, unlike a visible or video or whatever you want to call it, optical telescope, doesn't need a tube. And there's no
Well, an
lens.
optical telescope doesn't need the tube either.
It doesn't.
Right.
No,
Why does it have it?
it keeps
Straight
out
light.
the gray light.
Straight light. to get
Oh, I
rid of-
got you. Stray light. But for some reason, those waves of photons, they're still photons, right?
Yeah.
But they're
Mhm.
going at a
Mhm.
lower frequency. They
longer
can
wavelength.
they can permeate the clouds right out there in the
Yes.
Milky Way. And that's
They,
the whole
they don't
basis.
interact with really small things.
Okay.
Right.
So, and it's the whole basis of the Webb telescope. That's all lower level.
Well, Webb is just barely off optical into like near infrared. So
Yeah.
Oh, okay. Are there any ways that the real upper level, very high frequency waves, your gammas and your X-rays, they don't get collected or seen? They
Yeah.
they would fry the instrument, wouldn't they? Pretty
no,
much.
they get collected. There's
Right.
there's X-ray telescopes out there. There
Right.
and gamma ray telescopes out there.
Right.
Really?
When I,
Mostly in space.
yeah. When I was at Lockheed Research Labs, we worked in the soft X-ray. And so we basically build instruments that had coatings on them. So the X-rays would bounce and not go through the mirror. But we imaged the sun at soft X-rays. We're interested in the solar corona, okay, in particular.
But in my
Is it-
dentist office, they not only don't bounce, they go right through me,
Right.
which radio waves do too. Color doesn't. Color and visible reflects off. It's kind of interesting how all these different parts, frequency parts of the electromagnetic spectrum do so many different things.
Well, they interact with things that are near the size of their wavelength.
Right.
Oh, okay. But
Now-
for some reason, the high frequency ones like X-rays and gamma rays are really bad for your tissues, for example.
They're high energy.
Right. Yeah, they're very high energy, Ron.
Is that what it is?
Oh, yeah. Yeah.
What's the very highest, X-rays or gammas?
Gamma is
Gamma?
There's nothing higher than that. Nothing can go faster.
they sort of say anything over X-rays is gamma rays, right? I mean,
Yeah.
Okay. And there are some sources out there in space that send those things our
Yeah.
way.
now
Hopefully.
Ron, Tom is displaying how an X-ray telescope focuses X-rays. They're much harder to get to bounce off of stuff and to focus. But you can see what they do is they build these nested cylinders
Right.
in sort of a tube, like you're thinking of for an optical telescope. And the X-rays come in at kind of a grazing incidence and just
Right.
barely reflect off, but they hit a whole series of these things, and you can focus it and get an image.
Right. So yeah, when I was at Lockheed Research Labs, we were interested in, normal, direct reflection of X-rays. And so we had to fake the X-rays out by making these coatings where they would ring inside the coatings and then come right back out. The thing about the grating there that Chuck was mentioning, the one that's in the picture on the right, is the efficiency of the reflectivity is not super good. We were putting out 40% reflectance for our telescope coatings, the mirror coatings, okay? So you would look at the mirror, okay, and it would look like a conventional, mirror, parabolic, okay? But we would coat it with these structures. We were particularly interested in carbon and tungsten, okay? And it has to do with their index of refraction and, how they are able to basically reflect at normal, right? Dead on, okay, and reflect X-rays. If you didn't have these coatings, the X-rays would go right through. They go right through.
The lower waves, which are radio waves, I learned in my radio career,
Mhm.
can be generated in a man-made transmitter that uses sometimes a crystal, right, to make an oscillator.
For the frequency.
Mhm.
And the color spectrum can be generated by any light, I guess, depending on how it's filtered. Or how does the dentist office what does that machine do to generate X-rays? How in the world? What does any of you know?
It's like a high voltage discharge that goes on.
Exactly, Chuck. That's exactly it. And I forget what metal they use. We used to do a lot of our work at the U of A to basically look at crystal structure. And I forget exactly what the metal was, but you're right. High energy, you get these basically you get these X-rays. Okay. The particular technique we were using was called von Laue reflection. Okay, named after a physicist. But this would allow us to look deep inside a crystal and make sure that we're looking at particular axes of the crystal. I was particularly studying magnesium, which is hexagonal. So in the reflection of the X-rays, we were looking for 6-part symmetry, okay, and to see how far off it was. And we had what was called a goniometer that you would rotate into several dimensions to make sure you had that crystal dead on, okay. Well, I'm sure that was a lot of stuff, but anyway.
Has there ever been an attempt by science to generate gammas? Those are the big killers at the far end of the spectrum. Would that kill us or just be too much?
No, well, you don't want to stand in the beam, but
well, I mean, we do an X-rays, but it's probably low power, right? Just enough to.
Well, you don't stand for very long.
Right. And don't forget, the center of the sun generates, high energy gamma rays. But basically, these things become quenched as they work their way out to the solar atmosphere. Okay, where it only looks yellow, visible photons.
Well, tell me this: the spectrums, like radio waves at the bottom, are pretty. There's a wide spectrum there, and the color spectrum is so wide. How wide are those top end X-ray and gammas? Are they just dinky little parts of the spectrum, or are they wide like radio?
No. I mean, they are segments of the spectrum, just like visible. They're much wider than visible, but they're arbitrary things that we just call them.
Yeah. And Tom just pulled up a really nice diagram of the wavelength we're on. Okay. And you can see that when you're in the high energy, that's the left side, the gamma rays.
Oh, there it is. There it is.
10 to the minus 16 nanometers. Okay.
So they're very tiny wavelength, but they take up a really good portion of the spectrum there.
Yes, they do. Yeah.
Gamma's not even pictured.
Yes, it is on the far left.
Ron.
I don't see it. I see Y. Is that Y rays?
No, that's a gamma.
No, that's a gamma. It's next, Ron. It's the Gampal waves.
Oh, that's gamma rays. That's a broad
gamma
part of the spectrum, about as long radio waves on the bottom part. Okay.
Yeah.
Interesting. Oh, you answered my question. Tom, you're awesome. Tom Totten, coming up microwave.
Yeah, that's nice. Pulling this stuff in.
Well, a question for you, Chuck. Your friend who's dabbling with radio and all he gets is a squiggle. Why can't he turn that into a picture?
Well, you could turn it into a picture if you scanned continuously with the antenna, and then noted the intensity at each, I guess what you'd want to call pixel, each delta that you could move it in each direction. So that's how you could build up an image of it. But he's just got this little simple hand trainable antenna that you point yourself. So it's a little hard to build up an image.
Okay.
If you wanted, you could sit there and maybe put on a chart recorder that does it on paper, moving the thing back and forth and then superimpose the images and the lines and get some kind of image, just like a TV scans. The TV is just, or a CRT, one of the old type TVs, is just scanning a line across. And it just does it so fast that to you, it looks like a continuous image on the screen being built up.
Right.
I heard once, or I learned that the lower the frequency, now we're talking sound waves, your harbor buoys are usually low because it goes further. And I believe the same concept can apply to waves. Radio waves can go longer with the same amount of energy than the higher up rays. Is that possible? Do you know what I'm saying?
I don't think so. I mean, it depends what they're passing through, what they interact with. Because with sound, it's because it's traveling through a medium, through like air.
Right. Yes.
And it interacts with the air. And so you want a wavelength that interacts less with the kind of structure you'd find in the atmosphere.
Right. Yeah, that's critical what Chuck just said, Ron. Acoustic waves need a medium. E&M waves, electromagnetic waves, do not. Okay. In fact, they travel best without it. They travel best in vacuum.
That's true. You're absolutely right.
But you get the same kind of phenomena from acoustic. You could get diffraction through a doorway and things like that. There's a lot of interesting parallels. Although acoustic waves do need a medium. Okay, and here at room temperature they travel about 340 meters a second. Okay, a heck of a lot slower than light.
And people used to think when they saw that light had wave-like properties that it must be traveling through a medium.
Right.
It's a whole ether thing that in the 1800s people were trying to detect the ether.
Right.
So, they did these experiments where they saw that, if there is a medium as the Earth travels, you should see Doppler shifting, or you should see something going on with the ether.
Right.
And they did these tests and said, no, it doesn't seem to apply. So that's when eventually you get the equations telling you how these electrical fields and magnetic fields interact with each other to make this self-propagating wave that you don't need a medium.
Yeah, and it was Michelson and Morley, basically that, what was the critical pair that, basically said, you don't need an ether, you don't need a medium. And it led to special relativity, Einstein,
Out there in the Kuiper belt is New Horizons, which went past Pluto, as you well know, and it's still sending back with a radio transmitter about like a 40-watt bulb. We're still getting it.
Yeah.
I know it concentrates it, I guess, in a single beam, does it not, in its dish? And it's got to be directional. It's got to be locked right on the Earth. You would think just even a nudge would put it way off on the Venus or way off of the Earth.
Well, the beam still diverges a little bit, but yeah, they have to be locked fairly accurately. We're still talking to the Voyagers that are out there, way the heck out there. And detecting those, I've read somewhere, is the equivalent of detecting somebody lighting a match on the surface of Mars.
Wow. And every one of those probes and rovers and have to have a different frequency. What are they going to run out of frequencies on the radio scale for these places?
They don't have to have a different frequency. They just have to have a broadcast schedule so you don't stomp on someone else. Plus, if they're directional, you're directional when you look also.
I got you. Listen, we've run out of time, gentlemen. We did all right. I hate to say we did fine without you, Jerry, but we did miss you.
Get well, Jerry.
Next week. What I'd like to do right now is tell everybody how to see us or jump on board, join the club, even without us meeting at Herron Hall. It's SBAU.com.org, right?
Right. Org.
And get on board tomorrow night if you want. Our next podcast will be Series 1 for the year 2021 and episode 14 next Monday, the 31st. Guys, say hi to your wives. Well, you live with your wives. Just hug your wives, and we love them because they support us. And we'll see you next Monday. All right, everybody?
All right. Thanks, everybody.
All right.
Take care, Baron.
Take care, man. Bye-bye.
Bye.